Hi friends, welcome to my channel Easy Math. If you not yet like, share and subscribe my channel, please like, share and subscribe my channel Easy Math. So here we are going to discuss the topic is Introduction to the Trigonometry. So this is a very most important topic in our mathematics 10th class syllabus. So here what are the main concepts are in the introduction to the trigonometry. See here what are the concepts here. First one you have to learn the introduction, what is trigonometry, applications in daily life, and next angle and right angle triangle and trigonometric ratios and Pythagorean theorem, trigonometric ratios of some specific angles, trigonometric ratios of complementary angles and trigonometric identities. So these are the main concepts of the introduction to the trigonometry. So this is SEM 2 chapter 8. Okay, this is a very most important chapter. Okay, here first of all what is introduction here. So in earlier classes means in the 9th class, so already you know about the triangles. So here the some specific that you know that the right angle triangle. So here the in this chapter which is based on the right angle triangle we will define this trigonometry. Okay. So some right angle triangle we imagine in the daily life. We will see some three situations. What are those? See here. That is the first situation. So the class of students, some class of students they are seeing in a Qutub Minar. Qutub Minar. So some students are seeing in a Qutub Minar. Here the Qutub Minar here. Students are here. They are seeing looking like a Qutub Minar. So here the just you have to imagine form a right angle triangle. So the student looking in this position. So form a right angle triangle. So whenever can you find out the height of the Qutub Minar? Height of this Qutub Minar. Okay, so just imagine that is right angle triangle. See here then the second situation. The second situation, a girl is sitting on the balcony or a house of a bank of river. So here the some girl or house is there. So that girl is sitting on the balcony position. So here looking, see a flower pot here placed on the stair of temple. So beside the temple a flower pot is there. So she is seeing on the balcony of her house of a bank of river. See the between these this is the bank of a river. Means so you have to just imagine form a right angle triangle. It's a right angle triangle. The girl is seeing look like this one. So form a right angle triangle. So I have to find out this is a river. So bank of a river. So I have to find out the width of a. Can you find out the width of a river of this right angle triangle? Okay. Next, see this third situation. Here a girl is flying in the sky here. Hot air balloon. It's a hot air balloon flying a girl in the sky. So in the some situation here the girl is moving to the her mother. Her mother. So the position will be changed. Means so here the position will be changed means a girl and mother are here is there. So the position of the hot air balloon is in here. So form here this one here right angle triangle, here also right angle triangle. So we have to find out the altitude or height of the hot air balloon. Can you find out this one? So here in these three situations, so here the height of the Qutub Minar and width of the bank of river and height of the hot air balloon. In these three situations form a right angle triangle. Can you find out the distance and heights? Distance and heights they are using some mathematical techniques. That is a branch of mathematics. We are calling the trigonometry. Okay, here so one quotation is there here. This perhaps is nothing which is so occupies the middle position of the mathematics trigonometry. The sentence means the middle position of the mathematics as a trigonometry. That sentence who is said is J.F. Herbert. Okay, this is the introduction. Next to trigonometry. What is trigonometry? The word trigonometry derived from the Greek words. So here the three Greek words are there. Tri means three. Gonon means sides. And metron means measure. So in fact that so the study of trigonometry is the relationship between sides and angles of a triangle is called as trigonometry. Sides and angles of a triangle. So the relationship between the sides and angles of a triangle. So the trigonometry, the working of a trigonometry was recorded in the Egypt and Babylon. Egypt and was recorded in Egypt and Babylon. So the working of trigonometry was recorded in Egypt and Babylon. So who is the father of trigonometry? So the father of trigonometry is Hipparchus. Hipparchus. So he is a Greek mathematician. He is a Greek mathematician. He is a father of the trigonometry. And next, applications. What are the applications in daily life? So where you are using this trigonometry? You are using in daily life. What are the applications? What are the applications? Astronomy. You are using the astronomy. Navigation. Satellite navigation. Okay. And next, measuring the trigonometry, measuring in heights. Measuring in heights means height of the building and height of the mountain. And next, criminology. Criminology also you are using the trigonometry. And next, satellite navigation and developing the computer music. Developing the computer music. So here the computer music means which is in the form of the sine waves and cos waves. Okay, that's why I are using the also trigonometry. And next, electrical circuit boards. Electrical circuits boards. And next, in the chemistry means number theory. Chemistry means your number theory are using the trigonometry also they are used. And next, so height of the here the estimating the heights of oceans, heights of a oceans, etc. Okay, so these are the there are so many applications are there. So here the main applications you are using the trigonometry. Okay, and next, what is angle? So the angle is defined the amount of rotation of a revolving ray or terminating ray, which is reference to the fixed ray. That rotation, the amount of rotation is called as angle. So that angle is defined theta or alpha. See here, two rays are there. Two rays are there. This is OA. This is a fixed ray. OB. This is a revolving ray or or terminating ray. So the amount of rotation revolving ray or terminating ray with reference to the fixed ray, that amount of rotation is called an angle, that is denoted theta or alpha. This is the angle. Okay, so that angle is denoted B O A or A O B. Okay, so here the two angles are there, positive angle and negative angle. So if the rotating the terminating ray, which is in the anti-clockwise direction, that is called as a positive angle. So same here, the rotating or revolving ray is in the clockwise direction, that is called as a negative angle. See here. So this is the fixed ray, this is the revolving ray. Okay, this is the fixed ray. This is a revolving or terminating ray. Okay, this ray is the, they are rotating the anti-clockwise direction. Anti-clockwise direction, that is called as a positive angle. See here. So this is a fixed ray. This is a fixed ray. This is a terminating ray. So here the terminating ray is rotating the clockwise direction, means here clockwise direction means here take like this, means that angle is a negative angle. This is a terminating ray. This terminating ray is rotating the anti-clockwise direction, that is called as a negative angle. And next right angle triangle. Learn about right angle triangle. So this right angle triangle, so based on this right angle triangle, we will discuss the trigonometry chapter. So what is the right angle triangle? What are the angles? What are the sides? We will discuss. See here, suppose take one right angle triangle. So here right angle at take right angle triangle ABC, right angle at B 90 degrees. See here right angle at B 90 degrees is, this is B 90 degrees. So take this is A C. So this is a triangle, right angle triangle ABC. So here the this 90 degrees, these two angles are acute angles. Okay. So if angle theta is at vertices A, here the three sides are there. Three sides are there. What are those three sides means here? Hypotenuse, hypotenuse, opposite side, adjacent side. So these are the three sides of the right angle triangle. So how to identify these three sides in right angle triangle? So whenever the angle is vertices A, so in sometimes the angle is not given, we will treat it or we are mentioned not mention the angle theta. So you directly take as angle A, angle B, angle C. We will consider. Okay. Here the theta is given, angle theta is given. So how to identify the hypotenuse? So here right angle at B. So 90 degrees exactly opposite side is the hypotenuse. Hypotenuse. Okay. Simply HYP. Next here the angle theta is mentioned. Sometimes not mentioned. So they are given angle A, angle C, angle B. Okay, we will take. So here theta mentioned, the theta opposite to the side opposite to the angle A. That is side opposite to the angle A, that is opposite side. So the rest of the side is the adjacent side. Side adjacent to the angle A. Okay. Here 90 degrees opposite to the hypotenuse, theta opposite to the opposite side, and the rest of the adjacent side. We will see one more right angle triangle. So this is the right angle triangle. Right angle at B. This is A. This is C. So angle at C. Where is the? This is 90 degrees. So where is the hypotenuse? 90 degrees opposite to the hypotenuse. Okay. So theta angle opposite to the side opposite to the angle C. Okay. This is the opposite side. So the rest of the side is side adjacent to the angle C. Clear? So this is very most important. How to identify the three sides? Hypotenuse, opposite side, adjacent side. So very most important. So based on this right angle triangle, based on these sides, one exercise, first exercise is there. Okay. And next, trigonometric ratios. So we will see the trigonometric ratios. So here the ratios of different pairs of sides of a right angle triangle is called as trigonometric functions or trigonometric ratios. How many ratios are there? Here totally 6 ratios are there. 6 ratios are there. First one, sine ratio. Take here sine theta, cos theta. Third one, tan theta. These are the main 3 ratios. So the reciprocal. So remaining 3 is the reciprocal of these 3 ratios. Sine reciprocal is cosecant theta, cos reciprocal is secant theta, tan reciprocal is cot theta. So these are the 6 ratios. Okay. So the ratios of different pairs of sides of a right angle triangle is called as trigonometric ratios. These are the 6 ratios. So how to define the one by one? Okay. How to form a sine, how to form a cos, tan, cosecant, secant, and cot. We will discuss that one. See here, we'll consider a rectangle coordinate system as a OX and OY. So here from center draw one circle, take a point on circle P and and form a angle at make an angle here theta. Draw a perpendicular line PM. So here the form a 90 degrees. Okay. So this x is parallel to x-axis, take x, and PM is here parallel to y-axis, take this one. This side is y, and OB is the radius of this circle, that has take radius R. Here we know, so already discussed that before that right angle triangle, how to identify the 3 sides: hypotenuse, opposite side, and adjacent side. So here the 90 degrees opposite to the hypotenuse. So simply HY, hypotenuse. So here the theta opposite to the, this is the opposite side. So rest of the side is adjacent side. Okay. Here one by one. So first ratio, different pairs of ratios of sides. See here the first one, PM by OP. PM by OP. So that ratio is the side opposite to the theta by the hypotenuse. PM is called here side opposite to the theta by hypotenuse. OP is the hypotenuse. So we will consider this one. What you are calling here? This is a sine of angle theta. Sine of angle theta. So simply it denoted sine theta. What here ratio? Sine ratio is called as here the ratio of the opposite to the hypotenuse is called as sine ratio. Next, second one, second ratio. OM by OP. OM by OP. What here OM? Side adjacent to the theta. Side adjacent to theta by hypotenuse. So here the OP is the hypotenuse. That is simply called as cosine. Cosine of angle theta. So simply denoted this one. Sine. Simply denoted this is a cos theta. Cos ratio. So what is cos ratio? Is adjacent side by hypotenuse. Next, third one. Next, third one here the tan ratio. What is tan ratio here means? PM by OM. PM by OM. So what is PM? Side opposite to the theta. Side opposite to the theta by OM means side adjacent to the theta. Side adjacent to the theta. So that is simply called as tangent. Tangent of angle theta. So that is simply denoted tan theta. This is the tan ratio. What is tan theta? Here opposite side by adjacent side. And next the reciprocal. The reciprocal. So here the sine ratio means opposite side by means side opposite by the hypotenuse. Sine reciprocal is what? This is the sine reciprocal. Cosecant theta. So how to define here? So simply here the reverse of the ratios. OP by PM. OP by PM. So here the OP is what? Hypotenuse by opposite. Hypotenuse by opposite side. So that is simply they are called cosine. Cosine of angle theta. Simply denoted cosecant of angle theta. Simply denoted cosecant theta or cbse. Cosecant theta. And next fifth one, cos reciprocal, that is secant. How to define here? The hypotenuse by adjacent means cos theta. Here the cos ratio is OM by OP. Here the OP by take OM. What is OP? OP means hypotenuse. OM is adjacent side. So hypotenuse by the adjacent side. So that is denoted here the secant of angle theta. Simply denoted secant theta. Is the secant ratio. What is secant ratio here? Hypotenuse by adjacent side. Next, sixth one and last one here, cot theta. Cotangent means so the reciprocal of the tan theta. So what is cot theta means here what? So adjacent side by the opposite side. So OM by PM. OM by PM. That is equal to adjacent side by opposite side. Adjacent side by opposite side is called as cotangent of an angle. Cotangent of angle theta. So that is simply denoted cot theta. So cot ratio. So these cosecant, secant and cot are the reciprocal of the sine, cos and tan. Okay, these are the 6 ratios. These are the 6 trigonometric ratios. Okay, What is sine theta? Sine theta means opposite side by the hypotenuse. Cos theta means adjacent side by the hypotenuse. Tan theta means here the opposite by the adjacent side. And next cosecant theta means reciprocal of the sine theta, means hypotenuse by opposite side. And next secant means reciprocal of the cos, so that is hypotenuse by adjacent. And next tan, so here the cot is the reciprocal of tan. So here adjacent by the opposite side is the cotangent, that's simply denoted cot theta. These are the 6 ratios of trigonometric ratio. So you find the relations between these 6 ratios. What are the relations? We will discuss next. The relations of trigonometric ratios. How many ratios are there? 6 ratios. Sin theta, cos theta, tan theta, and their reciprocals. Cosecant theta, secant theta, cot theta. And how to find out the relations? See here. First relation is sin theta. What is the reciprocal of this one? 1 by cosecant theta, right? Cosecant theta transposed to this side. Sin theta into cosecant theta is equal to 1. So one relation. And next cosecant theta is equal to here 1 by cosecant theta is equal to 1 by sin theta. This is a relation between sin and cosecant. These are 3 relations. Okay. Next. Second one. Cos. Cos theta is equal to 1 by secant theta. 1 by secant theta. So a relation between cos and cosecant. So secant transposed to this side. Cos theta into secant theta is equal to 1. One more relation. Secant theta is equal to cos theta transposed to 1 by cos theta. So these are 3 relations, cosecant and secant. And third one, tan theta is equal to the reciprocal of 1 by cot theta. So here one more relation is cot theta transposed to the side, tan theta into cot theta is equal to 1. And next cot theta is equal to tan transpose to the side, 1 by tan theta. Okay, so relation between tan and cot. And next one more relation is there, important this one. Tan theta is equal to sin theta by cos theta. So relation between sin, cos, tan. How to write this one also? Sin theta into 1 by cos theta. 1 by cos theta, right? Secant theta. One more relation. So tan theta is equal to sin theta into cos theta also. So here the sin theta, how to write? Sin theta is equal to 1 by cosecant theta. 1 by cosecant theta into secant theta. That is equal to secant theta by cosecant theta. Okay, one more relation. So tan theta is equal to secant theta by cosecant theta. These are the very most important relations. Next, fifth one, cot. Cot theta is equal to reciprocal of tan, right? Cos by sin. Cos theta by sin theta, that is equal to cos theta into 1 by sin means what? 1 by sin theta. 1 by sin theta is equal to cosecant theta, that is equal to. Here cos theta is equal to what? 1 by secant theta into cosecant theta is equal to cosecant theta by secant theta is a one more relation. Cot theta is equal to cosecant theta by secant theta. So these are the 5 relations. Okay, sin, cosecant, cos, secant, tan, cot, and one more tan and cot. These relations are very most important in our exercise problems. Okay. Next, for example, based on these trigonometric ratios, for example, Suppose take a right angle triangle ABC. Right angle at B. AB is equal to 4 centimeter. BC is equal to 3 centimeter. And CA is equal to 5 centimeter. Find out the all ratios. All ratios means what? Sin A, cos A, tan A, cosecant A, and secant A, and cot E. Find out these six ratios. How to find out? See, take a right angle triangle A, right angle at B, 90 degrees. This is B, 90 degrees. Here the C. Here, where is the angle? We are asking the sin A, cos A, tan A, cosecant A, secant A, cot A. So A is the angle. So first of all, you have to identify the three sides. See here, 90-degree opposite is the hypotenuse. Okay, and here the all ratios are angle here A. So this is the angle. Opposite A versus opposite to the opposite side, and rest of the side is adjacent side. See here the given data is what? AB is equal to 4 centimeters and BC is equal to 3 centimeters and CA is equal to 5 centimeters. They are given. First find out the first ratio. Sin A. Sin A is equal to, what is sin ratio? What it is said sin ratio? Opposite side by hypotenuse. Opposite side by hypotenuse. What is opposite side? 3. Hypotenuse is 5. 3 by 5. Next, cos A. Cos A. Cos A means what is cos ratio? What it is said? Adjacent side by hypotenuse. Adjacent side by hypotenuse. What is adjacent side? 4 by 5. Adjacent by hypotenuse. 4 by 5. Next, tan. Tan A is equal to, what is tan ratio? Opposite by adjacent. So here the opposite, what is opposite? 3 by 4. 3 by 4 centimeters. And these are the three ratios. Next three ratios are what? Reciprocal of these three. Sin reciprocal is your cosecant. What is your cosecant? Cosecant A is equal to hypotenuse by opposite. Their reciprocal. Hypotenuse by opposite. That is equal to 5 by, just reverse. Next, secant. Secant means the reciprocal of cos, means that how to define hypotenuse by adjacent. Hypotenuse by adjacent. Hypotenuse 5, adjacent is 4. So here just reverse 5 by 4. Next, cot. What is cot? Reciprocal of tan. So here the just reverse adjacent by opposite. Adjacent side by opposite. So what is adjacent here? 4. Opposite is 3. 4 by 3. So these are the example. So based on this trigonometric ratios, we will discuss the first exercise. Okay. So next, Pythagorean's theorem. What is the statement of Pythagorean's theorem? In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of remaining two sides. Suppose take a right angle triangle. This is a right angle triangle. Right angle at B, here C. So this is the hypotenuse. This is the side. This one also side. Okay. So So what it is definition? Square of hypotenuse. Square of hypotenuse is AC square is equal to the sum of the squares of remaining two sides. That is AB square plus BC square. Where you are using this Pythagorean theorem. So in some problems they are given one side, they are not given one side. Only two sides are given. You have to find out the other side by using the Pythagorean theorem. By using the Pythagorean theorem, you have to use this one. So for example, by using Pythagorean theorem, for suppose in a right angle triangle, in a triangle ABC, a right angle at 90 degrees. Okay, see here AB is equal to 3 centimeters, BC is equal to 4 centimeter, CA only two sides are given, find out third side. So take a right angle triangle. So right angle at B 90 degrees and C here the A. Okay. Here the given AB is equal to AB is equal to 3 centimeters, BC is equal to 4 centimeters, and find out the AC. How to find out? By using this theorem, Pythagorean's theorem. So by Pythagorean's theorem, AC square. AC means what? A right angle opposite to the hypotenuse. This is the hypotenuse. This is rest of the sides here. This is side. This one also side. What is the formula here? AC square. AC square is equal to AB square plus BC square. What is your AC? We don't know that. We have to find out that third side. So AC square is equal to AB square. 3 square plus 4 square. 3 square means 9. 4 square means 16. So that is equal to 25. AC is equal to square root of 25. That is equal to 5 centimeter. So AC is equal to 5 centimeter. Okay. So that is the importance of the Pythagorean theorem. So in some right angle triangle, there are three sides are there. One side not given. Find out the third side by using the Pythagorean theorem. Okay. And next one.